Hello, everybody. It's 2 o'clock in the afternoon in Warsaw, and we are starting our UNIgreen JRC4 Biodiversity, Forestry, and Agroecology seminar. The seminar will be recorded, and all the recordings will be later shared with all the audience with our UNIgreen YouTube channel. All of the participants have their cameras and mics turned off. And if you would like to ask a question during the presentation or after during the discussion, you have the Q&A button on the top of the screen. We will start with a presentation and then it will be followed up by discussions and questions later on. And today our speaker is Giulia, right? That's how we should pronounce it, Giulia Santunione. And the presentation that we're gonna see today will be focused on climate-friendly parks as urban practice. And Giulia is a researcher in environmental and applied botany at the University of Modena and Reggio Emilia in Italy. And she holds a PhD in environmental engineering and Master of Science in biology. And I will not talk more about Giulia and her presentation because I will leave it for her to explain what's her background and what is her motivation. So I hope that we'll all have a really good presentation in front of us. And Giulia, we can start your talk. Maybe we can also start the presentation when you're ready.
Thank you very much for this invitation and this presentation. I just want to add some information about me. Yes, as a researcher in environmental and applied botany, my research is primarily focused on the study of the interaction between plants and environments. And in particular, in these last years, my research was focused on the analysis and quantification of ecosystem services provided by vegetation, in particular in the urban environments. And this also is the topic, the main topic that I'm going to talk about to you in this seminar, in this afternoon. Indeed, yes, I'm working at the Department of Life Science of the University of Modena and Reggio Emilia. That is a region, Emilia-Romagna region in Italy. And I want to talk to you about this climate-friendly park as a urban practice. And I will talk to you on an experimental case that we realized in the city of Reggio Emilia. The mission of this project called the Climate Friendly Park was primarily to contribute to the climate change adaptation of urban and peri-urban areas, primarily to countermeasure the phenomenon of urban heat island, intending to mitigate the microclimate, improving the green areas. This project is part of a LIFE project, a European project, where the municipality of Reggio Emilia was involved. And in this case, the LIFE project involved not only the city of Reggio Emilia, but 4 more cities, 3 cities located in Spain, Alcantarilla, Lorquí, and Molina de Segura. And the 4th city is located in Italy, Reggio Emilia. So the first mission was to provide a strategy to face the climate change that are occurring in the cities and improving the situation and the adaptability of the city of Reggio Emilia against the climate change. And the LIFE project was intended to get this mission, this goal, through a urban afforestation plan intended to greening the cities. So let's see how the project started. In particular, in fact, this the greening of the city of Reggio Emilia, according to this LIFE project called the Climate Friendly Parks, start with some criteria that have been selected through another LIFE project that is called Urban Proof LIFE project. Through this first LIFE project, we selected 4 criteria to select the most adequate areas in the city of Reggio Emilia to realize some climate-friendly parks. The first criteria is to find areas with medium height vulnerability to urban heat island. Then the parks that we choose should be areas with large enough to accommodate a number of plants as the project requests. And then we selected also areas that have been reported by citizens as insufficient shading, in order to improve this situation and also to stimulate the citizen to improve also the usability and efficiency of the park. So according to these 3 main criteria, we selected 4 green areas in the city of Reggio Emilia, where the aim of a climate-friendly park. The first park was called the Ferravilla Park, that is about 30,000 square meters. A second park was smaller, is Primavera Park. Then the third park was called the Grimadi Park, 30,000 square meters again. And the last park is Marco Biagi Park. That is the one that I will talk about. First of all, I want to introduce you the strategy that we use to make this park as climate friendly. Because we introduced the some nature-based solution, which are, of course, solutions that have been inspired by the nature in order to provide some ecosystem services. And in this case, we introduce green and blue infrastructures, and focusing on the green infrastructures that are mainly trees or vegetation solution. They provide evapotranspiration and shading phenomenon. The evapotranspiration is the combined process by which water is transferred from the land to the atmosphere through evaporation and transpiration from the plants. And heat plays, of course, a key role in cooling the environment, since it absorbs heat during the evaporization, while shedding is the reduction of solar radiation reaching a surface. And in this case, trees can play a really key role because they can shield light and radiation, helping to lower the surface and the pavement to air temperature gains and limiting heat absorption. In this case, to introduce some nature-based solution in these areas, we should select 3 species. That is one of the first action to plan. The species selection was based on chorotypes, so studying the chorotypes, and in particular, in our case, the first criteria was the criteria of autochthony, since we choose mainly species from the Po Valley, from our local region, but not only autochthony species. Indeed, we want to test also alternative plant association in order to assess and monitor the resilience of climate change, also of other kind of species, in particular the Mediterranean zone. The first nature-based solution that we introduced in these climate-friendly parks are the trees row, the linear trees row. In this case, usually these landscape elements is monospecific, so we use just one species to realize this row of trees with regular planting patterns. The species that are mainly used in our region are, for example, Tilia platyphilus, Tilia cordata, Acer campestre, Fraxinus excelsior. And the first and the main ecosystem service that they provide are shading and particular matter retention. Moreover, the second nature-based solution or landscape elements that we introduce in our park is the multi-specific meadow. This is a very part of the historical valley agricultural landscape, and multi-specific means that we introduce seeds from different families, mainly Fabaceae, Poaceae, Asteraceae, and the concept of multi-specific supports, for example, pollinator and wildlife, and a multi-specific meadow requires less maintenance than traditional lawns, and actually is more resilient to pest or climate stress. So it's support and provides in particular biodiversity, and also is important for education. The third nature-based solution that we include in our park are the hedge rows using shrub species. Also, shrub lines, shrub rows are part of the historical Po Valley agricultural landscape, and these are important usually to create a multi-layered vegetation. They have important effect on shading. Also, they has a role as a windbreak, and can provide also the ecological corridor in agriculture, but also in peri-urban landscape. And the last, not the very last, but one of the last natural based solution are the microforest. The microforest, also forest, are a method that is has been developed by Akira Miyawaki. That is a famous Japanese botanist, which involves planting a high diversity of native species very close together in order to accelerate natural forest grow. So the idea of Miyawaki for microforest is to plant a very high density trees with a small plot size, like 200 to 400 square meters. The important thing is to use a very high species richness in order to create also a multi-layered landscape. And the important thing that this kind of tiny forest is that they almost not have the necessity to maintenance, like pruning, weeding, irrigation, and so almost no planned maintenance have been considered. In our case, we used two types of microforest. The first one is a native microforest where the autochthony plant species have been included. Autochthony means from Po Valley, our region geographical area, while the second type of microforest that we realize is the adaptive microforest. In this case, we use also species from Mediterranean area, more adapted to future climate conditions. And our interest was to compare also these two kinds to different plant association in the same climate condition. This is the Marco Biagi Park area where we can find all the type of nature-based solution that we introduce. In particular, the green infrastructure that I just presented, and also a blue infrastructure that is a wetland, so a water basin. And now I will describe it in the details. In fact, in this Marco Biagi Park, we introduce a wetland that is connected also with a channel. In particular, the wetland has a pond. The pond area is about 150 square meters. The maximum depth is 1.2 meters. And one of the main feature is that the banks have a very gentle slope in order to create a ecotonal strip. Then the pond is connected with a channel which collects the overflow water from the pond. So the water level is variable depending also by the precipitation, for example. And so along the channel we have also the banks and the shores where we can find a hydrophilic and hygrophilic vegetation, even if meadow species and tree species. So now I can show you some of these species in the wetland. Some of these species have been introduced, like hydrophytes, Nymphea alba, for example, and Metaquatica, Callitriche palustris, Nopharlutea, and these hydrophytes are radicans, but we introduced, we could found also other species, nathan species, like, for example, Lemna minor. Along the banks and the shore of the pond, we could find other herbaceous species that after we can see in the details. Along the banks of the channel, we have as well hydrophilic vegetation, like, for example, Tifa latifoglia, Urtica dioica, Litrum salicaria, Carex pendula, Limniris pseudacorus. And we also found a lot of species along the shore. In fact, for example, we at the beginning introduced some three species along the shore. hygrophilic species like Halmus glutinosa, Salix alba, and Ulmus minor that are well adapted to this kind of ecotonal strips. The two microforests have been realized considering a high number of species. In particular, we have the species that we used to realize the adaptive microforest, and in red we can see the species that coming from Mediterranean zone, for example, Quercus frainetto, Acermon spessolanum, Cedis australis, Quercus silex, Fraxinus oxycarpa, Ostrea carpinifoglia. So the chorotypes of these species is Mediterranean or Euro-Mediterranean, and in this case we consider these species to characterize the adaptive microforest, in contrast to native microforest, where we introduce the species from Po Valley region. So we can find here a difference of the microforest in winter and in spring. As you can see, the microforest now is quite small. Indeed, the realization of these climate-friendly parks start in 2022 and finish in 2023. Here we can find the position and the placement of the shrub species that compose the edge rows, and we use mainly native species. To realize the tree rows, we use Tilia platyphilus, that is the common species of Tilia in our region. And then we arrive to the main goal of the environmental monitoring project that we performed on 2024 and 2025 during mainly the spring and summer period. So we monitor and evaluate the vegetation dynamics and all these net-based solution in order to first of all define the floristic biodiversity of this climate-friendly park, Marco Biagi. Then the second goal was to evaluate the growth performance of three species in the two different Miyawaki microforests in order to compare two different vegetal association. Then we wanted to quantify trees and shrub carbon stocks and sequestration as a long-term ecosystem service. Lastly, we assess also the microclimatic effect of each nature-based solution compared to the external areas. So to evaluate the floristic biodiversity, we use the bio and chorological spectra, and yes, we calculate the mortality rate. In order to evaluate the growth performance, we use allometric measurement and equation. Then we quantified to quantify carbon stock and storage. We use the I3 model, and the final we measure all the microclimate change, measuring air temperature, air relative humidity, soil temperature, and soil water content. So why biodiversity evaluation is important to evaluate and for this kind of environmental monitoring? First of all, because an ecosystem, of course, with a high biodiversity and a wide variety of biological form is more stable and resilient to disturbance, and so it is so important to improve the biodiversity level in a urban or peri-urban area as Marco Biagi Park. The monitoring of biodiversity can provide valuable data for conservation and for land management. Then biological spectra, for example, reflect the environmental characteristic and the degree of anthropogenic influence of an area. Lastly, the chorotype and then the chorological spectral give us important information about the distribution of plant taxa. And let's see something about the materials and methods, so how we do this environmental monitor. First of all, to monitor the biodiversity around the wetland area, we use the random quadrats method, designing 21 random quadrats and checking all the species into these quadrats. Then we measure also the plants vegetation into the water basin, into the pond, and we of course provide the species identification and classification for 2 years, for two years during spring and summers. Then we, of course, provide the species identification and classification of each individual tree and shrub in each microforest and all the hedge rows and tree rows through labeling and counting species and dataset elaboration. We calculate the mortality rate in the microforest. To evaluate the growth performance, we measure some allometric measurement like height and diameter at breast height, calculating also the slenderness ratio. Moreover, we evaluate also the relative growth rate. So, first of all, the slenderness ratio, that is the rate of, between height and the diameter breast height, are generally associated with a greater structural stability. Because when heat becomes becomes higher, it means that the plants is growing in particular in the height. So it is an indirect indicator of competitiveness. While if this rate is getting lower, it means that the tree is gaining stability. Then we measure relative growth rate, and it is important as an indicator of ecosystem function and species fitness. To measure the height of the tree, of each trees and shrub, we use a clinometer that uses 3 points, and he calculates automatically the height of each trees. And then we use also a meter to measure the diameter of each plant. And these two parameters have been used to calculate the rate among height and diameter breast height, that is called the slenderness ratio. The diameter has been, the measurement of the diameter have been collected at 1.3 meters from the soils in a normal situation, but it could be also in a very different situation according to the plant and each individual forms. Then, to quantify tree and shrub carbon stocks and sequestration, we collect data about all the species, all the allometric measurement, and then we use the i3 Eco software that use and applied species-specific allometric equation from literature to elaborate data about carbon sequestration. That means the process of capturing and storing atmospheric carbon dioxide, and it is temporal parameters because it is the active process of removal. And then we calculate also carbon storage, that is the result of that process, since the carbon storage means the total amount of carbon that is kept and held in the trees. So it is calculated in kilograms. The allometric equation estimates the carbon that is stocked or sequestrated by the above ground biomass and also below ground biomass. Lastly, we evaluate also we assess the macroclimatic effect of greenery intervention of each nature-based solution that we introduced in Marco Biagi Urban Park, and we evaluate and we collect measurement during spring, summer for 2 consecutive years with mobile probes in 12 points inside the park and in each nature-based solution. So, for example, inside each microforest, outside each microforest, around the wetland, around the row edges and tree rows. And then we collect measurement also in the external areas, in particular at 100, 200 or 300 meters far from the parks. So here, let's start with some results. First of all, results about biodiversity. I develop biological, in this case, biological spectra. And in this case, we found that just in 1 year, some rooting hydrophytes disappear, like for example Sparganium erectum, while Lemna minor appear, for example, that is hydrophytes. Interesting, along the channel and along the banks of the wetlands, just in 1 year, the scapose hydrophytes enhance a lot, more species appears just in 1 year, as Onobrichis vicifolia, Lysimachia vulgaris. I forgot to say that just in 1 year we found the 69% more species than the previous year. So this indicates, for example, that of course we are in a starting ecosystem situation that is not stable, but this enhancement in species richness is quite strong and surprising. So, going ahead, okay. Along the banks of the wetlands, we found other species like Veronica persica, Trifolium repens, Chicorium intubus. These are all species that are very tolerant to anthropogenic disturbance, for example. Also, in the pond, the population of Tifalatifolia, for example, expanded in a significant way. And about the chronological spectra, we found some interesting points. For example, first of all, the subcosmopolitan chorotype is the most represented, but just in 1 year, the Eurasiatic chorotypes gets lower, while the Mediterranean chorotype is getting higher. So the wetland ecotone habitat in the Marco Biagi Park is getting more Mediterranean species. Okay. Now, talking about the mortality rate of microforest, we found a very, very low mortality rate just in 1 year. So between 2024 and 2025, just very few plants died, and the mortality rate in both forests stayed below the 3%. Here we have some results about relative growth rates in, first of all, adaptive microforest. We divide, we make analysis identifying the species of Morus alba, Prunus, Maleb, Ostra carpinifolia, and Quercus ilex are the species that increase mainly in the growth rate in terms of the diameter. Here, the native microforest, in the native microforest, the species that provide a higher relative growth rate in terms of diameter overall are again Morus alba, in this case Prunus avium, and Populus alba. Here we have the result about slenderness ration, that is the ration between height and diameter breast height, that indicate has that the plant is becoming more robust and structurally stable of knot. And in this case, we found in very few cases a positive slenderness ration, and in the most of the cases, this rate stay negative, and this that means that the diameter of the plants is growing, and so the trees in both type of macroforest are getting more stable. Okay, here we have some results about carbon stock and carbon sequestration, and it is quite impressive that, considering all the nature-based solution that we included in Marco Biagi Park, in just 1 year, we gain more than 140% of carbon storage and more than 70% of carbon sequestration, and this thanks, of course, to the gaining of trees and shrubs in terms of height and yes, and here we have the species more efficient in carbon stock and carbon sequestration. The Quercus frainetto and Quercus robur are the most efficient species in this kind of ecosystem services, and it depends, of course, on the relative growth rate and also on the number of plants of each species that we introduce in each urban nature-based solution. Here we have the results about the microclimatic mitigation, and okay, it's quite small, but we can find, for example, in the first year of the monitoring, that in the 2 microforests, the air temperature stay lower than the other kind of nature-based solution, and in particular, if we compared the air temperature with of the microforest with the external areas. Here we have the result of 2025 from air and air temperature and relative humidity, where we can find a similar trend, but interesting also the data about the soil, since in the microforest, that is this quadrant, this plot and this plot, the temperature of soils remain lower than in other parts of the parks, and it is lower also along the edge rows, maybe thanks to the herbaceous vegetation that grow near the edge rows. Here we have elaborated the delta, the differences of air temperature between each nature-based solution and the external areas, and we found that the microforests are the nature-based solution that mainly provide the microclimate mitigation, since, for example, in 2024, around the microforest, the air temperature was 3 degrees less than external areas. And here we have the same trends about the soil parameters. Another evaluation that is on run now is about the NDVI, the normalized different vegetation index, that measure the presence, the density, and health of vegetation, and we are evaluating through the remote sensing analysis using the image from Sentinel-2 that has 10 square meters of resolution, and use the 2 bands, number 8 and number 4, to calculate NDVI. And we evaluate the NDVI over the Marco Biagi Park since 2021, so before the intervention and afterwards. And as we can see, the NDVI is getting higher year by year. It means that the vegetation is more dense, temperature, and this is the last image from 2025. Then we calculate also the value of NDVI, and we can see how it has changed during the last 5 years. So lastly, this is another ecosystem service provided by plants. So the capture of particular matters from leaves. We are evaluating the capacity of the species to capture and to entertain dust and other particulates in adaptive and native microforest. And just on the first year, we found that Fraxinus excelsior is the species that mostly has this capacity. So to conclude, we can say that nature-based solution in Reggio Emilia improve urban microclimate and carbon storage as ecosystem services. All the environmental device implemented in this case study in this Marco Biagi Park are improving microclimate, especially in terms of summer temperatures reduction compared to the external areas. We see that some few species dominate in terms of carbon stock, maintaining a diverse species composition that remains essential for promoting ecological resilience. These findings can show that how nature-based solution remain and is a key tools for mitigating urban heat island effect in the cities and promoting climate resilient and healthy cities. So thank you for your attention. I want to thank also my colleagues, in particular Federico Zanardi, a PhD student here in Unimore that helps in the environmental monitoring assessment, and the Professor Elisabetta Sgarbi. Thank you.
Thank you, Giulia, for this really wonderful presentation. As I'm a forester, I've learned a lot about parks and how to master the nature-based solutions in them. For all our attendees, on the top of your screen, you have Q&A button that will follow with asking questions to our presenter today. So you can create posts. I'll be reading them out loud for Giulia. And in the meantime, when you'll be preparing your questions, I have some questions that I'll start to ask, maybe some very small ones in the beginning. The thing that was most curious to me was, as I mentioned, I'm a forester. You mentioned that diameter as breast height was measured at 1 meter and 40 centimeters from the ground, and we
30.
do it one. Okay, because on the slide I saw 140. That's why I was to ask.
Okay, sorry. No, we measure 1.30. Maybe there is an error in the slide. 1.30
yeah, okay,
centimeters.
So we do the same. I was just curious about that. So maybe I will start from the last topics. So my question would be also, because you mentioned NDVI, what time of the year did you measure it? Was it a particular moment, or was it like an average for the whole year?
Yes, it is in particular moment from the beginning of May at the end of September. So we choose the images from Sentinel-2 according, the best images in this range in this period. So late spring and the summer period.
Okay, so mostly vegetation season, right?
Yeah, vegetation season. We use some also Google Earth engine in order to develop the NDVI. And also we choose only images without clouds. So mainly sunny days. More or less, we calculate NDVI using 30 to 35 images.
Okay, so it was more like an average per year, right?
Yeah, per year, okay. Of course, per year.
Yeah, sure. And you mentioned that there were some air temperature differences between different types of your nature-based solutions, for example, the different types of Miyawaki forest. Have you tested it statistically? Was there a significant
we
difference?
tested. Yes, we tested also statistically, and we found we didn't found statistical differences between the two kind of microforest in both of the years. But we found some statistical differences. The microforest and the other nature-based solution. Yes, so the microforests are the ones that provide an improved mitigation in this case. But yes, they don't find the statistical differences among the two types of microforest. In this case,
okay.
in this moment, but yes, we the microforests have been planted in 2022 and finished in 2023. So they now are quite small. We would like to follow the growth because now, yes, the plants are getting higher, but not to maybe to see a more strong differences among between the two. I mean.
Yeah, because that was one of my questions as well. Because if I understood correctly, those trees are not very big yet. They were like up to 5 years.
The mean, yes, not yet 5 years, but now 4 years.
Okay.
The height now is between 3-4 meters. The average, of course, but in this average we have some shrubs species, some tree species that are getting taller, and maybe some of them now are 6 meters, but yes, not so tall has the final shape, I mean, according to the species.
Yeah, sure. I mean, they still have time to grow, right? So we'll just have to wait for them. I encourage our participants to maybe ask some questions. If you don't want to use Q&A, we can always give you voice if you raise your hand or leave us a comment that you want to talk on camera and with microphone, just in case. I'm checking that there's no questions yet. I have 2 more, so maybe we'll be waiting for our participants. One of them is, you mentioned like a couple of methods, I think 7 of them that you were combining in one place. Would you recommend any particular one of them as the most promising for climate-friendly park? I mean, if you would have to choose, which one would it be?
So the method you intend, the type of nature-based solution?
Yeah.
Okay. So the best one. Of course, it depends about a lot of features. Okay. The blue infrastructures, so the wetland, for example, is a very nice nature-based solution because it gets at the same time climate mitigation. Theoretically, no, because water can provide a lower of temperature and also provide an increase and supports increase the biodiversity, plant biodiversity. Not only plant biodiversity, but when we have a wetland, we can also reach an increase of animal biodiversity. So that is important as well for urban and peri-urban biodiversity conservation, for example. Of course, the use of tiny forest and microforest could be very efficient if we have some peri-urban areas, and we wanted we have the aim to mitigate the temperature, while, for example, we can use tree rows or shrub hedge rows in the areas that are highly used from citizens, because they can provide in one time shading and evapotranspiration. Of course, the trees rows can mitigate the temperature lower or in a less efficient way than a microforest, but can be more adequate in some areas where the citizens usually need to walk or stay. So the type of network-based solution mostly depends on the kind of green areas or urban areas that we want to renaturalize. I mean,
yeah, okay, I understand that. So you have to tailor your the work you do to the needs you have in front of you. So that's totally understandable. Okay, I see no questions. I see no questions asked in the conversation. So if in any case, if our audience have any questions to our presenter, the email of Giulia can be seen on the screen. So I think that you can drop her an email and asking maybe some details on the presentation. So it was a really nice work, and thank you, Giulia, for this seminar. I really learned a lot here. I have just one announcement I would like to make at the end. So I'll share my screen for a moment. We just saw a presentation from Italy, from Unimore, about climate-friendly parks. And we have an upcoming seminar that will be held in 2 weeks' time by Helia Marchante from Portugal. She'll be telling us a story about a gall wasp, and that is controlling an invasive wattle. This is a totally different topic from my perspective, which might also be very interesting. So I invite all of you to joining us in 2 weeks' time. It will be 14th of April, Tuesday at 2 p.m. Central European time. So I hope you'll find some moment to join us there. And thanks again to Giulia for this seminar, and thanks to all participants for joining us today. I hope you had as wonderful experience as I had. Have a good day. And Giulia, if you can stay a moment with me and see the rest on the next seminar. Bye-bye.
Okay. Thank you very much to all the listeners.